Section 4.6, graphs of tangent functions. So we've already looked at cosecant and secant, which are the reciprocal of sine and cosine. Now we're going to go ahead and look at tangent functions, which is sine divided by cosine. So we're going to look at the values of force. So we got pi over 4, pi over 2, 3 pi over 4, and pi, and then we have some negatives in there as well. So what we're going to be looking at in terms of the unit circle would be at 0 radians, which would be 1 comma 0. We'll also look at the 45s, which are your square root of 2 over 2, square root of 2 over 2, and then once again the quadrantals as well. So I'm going to go through and label each of these ordered pairs that we are going to need to do the t-chart. Okay, and then also the 45s. I won't put all those in, but that's where they're located. And tangent of 45 is 1 or negative 1, depending on where the location is. So we're going to take our graph and we're going to cut it into each of these, which is in fourths. So each one of these marks or squares represents a fourth. So this would be pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4 is 2 pi. And then we'll also go in the negative direction, once again going by pi over 4 fourths. And so I'll stop at negative pi on that one. And so when we look at these values and we want to know what tangent of x is, remember tangent is equal to sine of x divided by cosine of x, which is y divided by x when we are on the unit circle. And so you're going to look at the ordered pair and take the y divided by the x. So for example, on negative pi over 2, which is going in the opposite direction but still located right here, you will take negative 1 and divide it by 0. And negative 1 divided by 0 is undefined. At negative pi over 4, that's right here, so that's your 45. That would be negative 1. And then at 0, you have 0 divided by 1 is 0. Pi over 4 would be 1. Pi over 2 would be 1 divided by 0. So once again, we are undefined. 3 pi over 4 in quadrant 2 would be negative 1. Pi would be 0 divided by negative 1, which would be 0. 5 pi over 4 is another 45, but it is a negative divided by a negative, so that's positive. 3 pi over 2 is the same thing as negative pi over 2, so therefore that is undefined. That's negative 1 divided by 0. 7 pi over 4 is the same thing as negative pi over 4, so that's negative 1. And then 2 pi and 0 represent the same thing. So went through a couple different periods here. Undefined negative 1, 0, 1. Undefined negative 1, 0, 1. Undefined negative 1, 0. And then 1 on the next one. So what you're looking at here is the period. As it starts to repeat, you see each of those values. So let's go ahead and graph this and see what we get. We have our y value. I need to get those numbers in there. Make sure you always label your x and y axis. At the undefineds, we have vertical asymptotes. So at negative pi over 2, we have a vertical asymptote. At pi over 2, we have a vertical asymptote. And then at 3 pi over 2, we have another vertical asymptote. And obviously this continues as the graph continues. At negative pi over 4, we're at negative 1. 0 is at 0, crosses the y-axis. Pi over 4 is 1. And then at pi over 2, it's undefined. 3 pi over 4 is negative 1. Pi is 0. 5 pi over 4 is 1. And then it's undefined at 3 pi over 2. 7 pi over 4 is negative 1. 2 pi is 0. And then the next one would be at 9 pi over 4, which would be 1 again. And so your graph of a tangent function will look like this. Okay, and so I have about almost 3 periods here graphed. And so when you look at your periods, pay attention. Now, in terms of how long the graph repeats, we talked about periodic properties before, but if you look at this, the difference between negative pi over 2 and pi over 2 is a period of pi. Same thing here between pi over 2 and 3 pi over 2 is pi. So where sine and cosine and secant and cosecant had a period of 2 pi, tangent appears to only have a period of pi, which is correct. So we'll have to now adjust in terms of what we do in terms of finding the period and the interval. Pay attention to that as well. All right, let's take the parent function for tangent, f of x equals tangent x, and find some of the important parts. The domain. So the domain is going to be x such that x cannot equal, and if you go back, it cannot equal pi over 2. That's where that first vertical asymptote is. So it cannot equal pi over 2 plus, and then it happens every period. So pi in, and then we'll say where n is an integer. And so kind of just to verify, if I plug in, n is 1, then pi over 2 plus pi would be 3 pi over 2. And 3 pi over 2, there's another vertical asymptote. All right, the range will be all real numbers because the graph goes up and down forever. There is restrictions to the domain, but not to the range. The period now, if you go back and we talked about this, the period is how long it takes the graph to repeat, which is pi units. So sine, cosine, cosecant, secant had a period of 2 pi, but with tangent, it'll be pi, and its intervals will be pi over 4. It is an odd function. If you have tangent of negative x, we're going to rewrite that as negative tangent of x. And think about what an odd function is. So when you have that value at, let's say right here at pi over 4, 1, then when it's an odd function, it's symmetric to the origin as you rotate 180 degrees. So then negative pi over 4, negative 1 should also be a point, and therefore it is. And then the y-intercept crosses at 0, 0. The zeros of the graph, x is equal to, and if you go back, you can see it happens at 0, pi, 2 pi, and we can also go in the other direction. So we'll just say x is equal to, negative pi, comma, 0, comma, pi, and it just represents all those values. And then the same thing in terms of your vertical asymptote. We can say, and kind of go back and look, your vertical asymptotes occur at negative pi over 2, pi over 2, 3 pi over 2, kind of once again that same thing in terms of your restriction of what your domain is. And so for your vertical asymptote, x is equal to pi over 2 plus pi n, where n is an integer. So that relates right back to the domain where our restrictions occur. We're having vertical asymptotes as well. So that kind of represents the general idea of what the parent function looks like and some of the characteristics it has. And so now as we kind of look to make sure that we know how to graph the tangent function, there is no amplitude, just like cosecant and secant. The graph goes on forever, but we still need to know what that a value is. So we don't want to ignore the fact that even though there is no amplitude, we still need the a for the graph because that's going to represent our vertical stretch or compression. The period, instead of being 2 pi divided by b, now it's going to be pi because the period of the original function is pi units. And so that's something you're going to have to be careful with now that we're on to tangent. So the interval, therefore, is the period, once you find that, still divided by 4. So still those important parts are at the fourths. The asymptotes happen at the beginning and the end of the period. So when you have your tangent graph, they're always going to happen here and here. The x-intercept will always be in the middle of the asymptote. And once again, if we shift up or down, it's going to change in terms of not being necessarily the x-intercept, but it'll be the middle of the asymptotes where that occurs. If a is greater than 0, the graph will be increasing. If it's less than 0, then it's a reflection. And then these points would get reflected below, and this point would get reflected above. And so now you would see a decreasing graph. So when a is less than 0, it'll be decreasing. When a is greater than 0, it'll be increasing. So really that's it for the notes. I'm going to go ahead and do 2 examples so you can kind of see what it's going to look like for tangent functions. So the amplitude, same as cosecant and secant, there is none, but I am going to put a is equal to 2, but I'm going to write the word none because there is none, but a is equal to 2 is something I need to remember. The period is pi divided by b. In this case, b is a fraction, so we're going to multiply by the reciprocal, 2 over pi, which will give the period to be 2. The interval, you'll divide into fourths, so that'll be 1/2. There is no reflection. There is a vertical translation. It will be shifted up 1 unit. And then once again, the horizontal shift, that's changing your x value. You don't have anything inside that parentheses that's changing that x value. So therefore, we have no horizontal shift. So now we take the graph and we start breaking it up into our intervals and our periods. So 1, 2, 3, 4, that represents one period, which is 2, and each interval is a half. So 1/2, 2/2, 3/2, and 4/2, which would be 2. So I reduce the ones I could. I'm also going to go in the other direction, -1/2, -1, -3/2, and -2. The a value is 2, so we'll let each square represent 1 unit. And it is getting shifted up 1, so we're going to take this x-axis and shift it up 1 unit. So this is kind of your new middle there. There is no horizontal shift, so we don't have to worry about that. And then, where does everything go? Remember, the tangent graph, when you go back and look at the parent function of the tangent graph, it starts at the origin, and then it's going to be increasing. So your vertical asymptotes occur in each direction on the -2 intervals over to the left and 2 intervals over to the right. So my vertical asymptotes will occur at -1 and +1. And then if I wanted to do another one, I'd have to go out to 3, because that's one period is 2, so that'll be another vertical asymptote there. So tangent starts in the middle, and it is increasing, but the a value is 2, so make sure you stretch 2, so you can see that the graph is increasing. Same thing on the next one. I'll graph 2 periods so you can see, and then graph in the tangent line the best you can there. And so there's 2 periods of the tangent function for 2 tangent pi over 2x plus 1. Now let's also include or talk about the domain. So the domain is x such that x cannot equal, find that first vertical asymptote at 1, so x cannot equal 1 plus, the period is 2, so we'll say plus 2n, where n is an integer. And so at 1, and if n's an integer, you'll add 2, which will put it at 3. Add it again, you'll get it at 5, and so on. So that's your domain, and then your range is all real numbers, which will always be true for tangent. It'll always be all real numbers. There's no break in the graph of the range. And don't forget, after you graph this, if you're concerned about, did you do it correctly, you can plug in a couple points if you need to. I mean, you're basically saying that y is equal to 2 tangent. Let's just plug in 0. So if I do pi over 2 times 0 plus 1, what would that equal? Well, that would be 2 times tangent of 0 plus 1. Tangent of 0, which is over here at 1, 0. So 0 divided by 1 is 0. It would be 2 times 0 plus 1, which would be 1. And you can see that's where we graphed it. So when x was 0, y was 1. Now that's just one point, but it gives you a good idea as to, did you do it correctly or not. Alright, in the last example here, f of x equals 2 tangent of x plus pi over 4. So your amplitude, none. Once again, we want to know what the a value is, so we'll say a is 2. The period is pi divided by the b value. Now, the number in front of x is just 1, so we don't have to factor anything out, so it's just pi divided by 1, which is pi. And then you break your interval up into fourths. We have no reflection, no vertical translation, because nothing is being added, whether it's in the front or 1 plus something or in the back or the front. It doesn't matter. Just make sure is the value being added to the function, so we don't have any of that. But we do have a horizontal shift. So it's x minus -4, that's why it's plus 4, so it does go to the left pi over 4 units. So we go ahead and mark, once again, our x-axis to indicate that our period is pi, and our intervals are at pi over 4, label the entire x-axis. So pi over 4, 2 pi over 4, 3 pi over 4, and then pi, and then once again you can also go in the negative direction and label those intervals as well. Also, don't forget to label your y-axis. Don't assume that I know what you want those values to be. And so now look at your horizontal shift. Now we're going to shift the graph pi over 4 units to the left. So the graph, this isn't a vertical asymptote, this is just the shift. So this is left pi over 4. I'm not indicating that's a vertical asymptote, just the graph is getting shifted left. So now we have tangent. We know the a value is equal to 2. So this is kind of our new starting x-axis. So remember, your asymptotes occur 2 to the left and 2 to the right of that middle. So 1, 2, 3, 4. We'll have one more all the way over here at 5 pi over 4. And that'll give us 2 periods to graph. So we're going to plot the points in the middle. We didn't shift it up or down, so we'll have one in the middle, and it is increasing because no reflection, and it is the a value of 2, so it will get stretched vertically by 2, and we can do one more period where the graph is increasing. So the graph will look something like this. And there you go, and that's the tangent graph with a horizontal shift as well. So you can see the way I indicated that wasn't a vertical asymptote, that it represented that shift in the graph. And lastly, we will write down the domain. So more practice on domain. X such that x cannot equal, and once again find that first vertical asymptote at pi over 4, plus the period is pi. So in pi, where n is an integer. So it occurs every period, so find the first vertical asymptote and just add n times that period, and that will get you to the next one. So pi plus pi over 4 is 5 pi over 4, and that's where that next vertical asymptote is. The range is negative infinity to infinity, which is all real numbers.